This video will talk about the different transformations of functions. In mathematics, transformation refers to the changes in the location, orientation, or size of parent functions. Speaking of parent functions, it is important that you know how the graph of a parent function looks like and its corresponding equation because they will be the baseline of our transformations. Please take note that in this video, I'm only going to use two parent functions, the quadratic and the exponential functions. Let's take a look at them. Alright, so this is the parent function for the quadratic function. So as you can see, it's a parabola, and the equation of the parent function is this, f of x equals x squared. Take note, f of x is just equal to y. That's the same as y. So f of x equals x squared is your equation, and this is your graph. So as you can see, I have highlighted here the five important points in our parabola. So as you can see, this point here, our quadratic function passes through the point 0, 0, and then 1, 1, and negative 1, 1, and then 2, 4, and then negative 2, 4. So take note of this. This is the baseline for our quadratic function. Next is the parent function for the exponential. So this is our baseline graph for the exponential, and this is your equation. F of x is equal to 2 raised to x. That's the equation for the parent function of the exponential. Now, as you can see in this parent graph for exponential, these are the three important points that I highlighted. So starting the graph goes through negative 1, and then 1/2 or 0.5, and then 0, 1, and then 1, 2. So take note of the parent function for exponential. Now that you've seen the parent functions, let's now go to the first transformation, the translation. Alright, so we have here the parent function for the quadratic, and here's the equation, f of x equals x squared. Alright, now let's see what will happen to our parent function if we add a number. For example, so from x squared, it will become x squared plus 2. All right, so let's see what will happen to the graph. Here's the graph for x squared plus 2. All right, so as you can see, that graph there, which is for x squared plus 2, the graph from the parent function, the green one, it moved 2 units up, right? 2 units up. So that's the effect of adding a number. What about if we subtract a number, just like this one? So instead of adding, we subtract a number from our parent function. So parent function minus a number, let's say minus 2. Let's see what will happen to the graph. All right, so as you can see, this from the green one, x squared, and if we subtract number 2, the graph moved down 2 units. All right, so adding a number, we can generalize from here. If we add or subtract a number from your parent function, the effect on the graph is it's actually a vertical shift, a movement either up or down. If you add a number, the graph will move up. If you subtract a number, the graph will move down. So you call it a vertical shift. All right, next. So we have here again the quadratic function, the parent function. The equation is f of x equals x squared. All right, now this time, what if we add a number, not after x squared, but we add a number to x? So just like this, something that looks like this. So instead of adding the number after x squared, we add the number to x. So we have there a parenthesis, x plus 4, and then we square it. Okay, let's see what will happen to the graph. And here's the graph for this. All right, here. So as you can see, the graph from your parent function, x squared, and if you add a number to x, all right, I'm adding a number to x only, so that's why you have there a parenthesis, x plus 4. The graph moved 4 units to the left. So if you add a number, that graph will move 4 units to the left. All right, now what if this time, instead of adding, we subtract a number? So something like this, x minus 4 squared. We subtract a number to x. The effect on the graph, let's see what's the effect on the graph. Here's the graph of f of x equals x minus 4 squared. Right? Look, so the graph moved 4 units to the right. Okay, so we can generalize here. If you add a number to x, okay, I'm saying adding a number to x, your graph will move to the left side. But then if you subtract a number to x, just like x minus 4 squared, your parent function will move 4 units to the right. All right, so we have here the parent function for the exponential. So the equation is f of x is equal to 2 raised to the exponent of x. So now, this time, what if we put a negative number in front of the parent function? So from 2 raised to x, we put a negative, something like this. We put a negative, this negative sign in front of the 2 raised to x. Let's see what will happen to our parent function. So as you can see, that green is our parent function, and if we put a negative in front of it, the graph will become this. All right, so what happened actually here is it reflected, there is a reflection, and the reflection is with respect to this line. This serves as the mirror. The x-axis is a mirror. So when you put a negative in front of the parent function, your graph, the parent function, will be reflected with respect or reflected across the x-axis. So there's a reflection across x-axis. What if this time we put the negative in x, not anymore in front of 2 raised to x, but this time in front of x, something just like this. So we have 2 raised to the negative x. We put the negative in front of x. So let's see what will happen to our parent function. All right, there you go. That's our new function. If we put a negative in front of x, what happens actually here is that from our parent function, it was reflected across the y-axis. This time, the line of reflection or our mirror is the y-axis, and it the parent function was reflected across the y-axis. So that's why this is the new graph. So if we generalize here, if we put the negative in front of the parent function, just like the negative 2 raised to x, the graph will be reflected across the x-axis. So your x-axis is your axis, your mirror. But if you put the negative in front of the x, just like 2 raised to negative x, the graph will be reflected across the y-axis. So your y-axis this time is your mirror.